Hello, today I'll be coding this animated pie. So let's get started. First of all, I'm going to have an SVG element, and the slices are going to be path elements, and I'm going to have a number of slices, 6 of them. So here I'm going to have a loop. Okay, and here I'm going to get the SVG. So document query selector SVG, and I'm going to set a size for this, and then I'm going to compute the top left corner coordinate, which if I want to have the 0, 0 point dead in the middle, then that means it's going to be minus half the size. And now I'm going to set a view box here, so set attribute and view box, and that's a capital B, otherwise it's not going to work. Then I'm going to have the coordinates of the top left corner along the 2 axes and the dimensions along the 2 axes, and then I'm going to join this with a space. Okay, now the next thing that I'm going to do is get the slices, and this is going to be a node list, query selector all path, and I'm going to get the number of slices, which is the length of this node list. Okay, now the next thing that I'm going to do is set a radius, and I'm going to take it to be a quarter of the SVG dimension. And then I'm going to compute the angle of a slice, actually just the half angle of a slice. So that's going to be pi over the number of slices. And then I'm going to compute the endpoints of a slice. Actually, just one set of coordinates, because the x coordinate is the same for both, and the y coordinate just flips sign, plus minus plus minus. So that's going to be r times cosine of the half angle, and it's going to be very similar for the y, except this is obviously going to be y, and this is going to be sine, not cosine. Okay, now I'm going to have a loop. So for I from 0 all the way up to ns, incrementing by 1, and here I'm going to use a function, set state, and the thing here, let's see, function and here I'm going to set for the slice at index I, I'm going to set attribute, this is going to be the D attribute, and I'm going to start at the 0, 0 point, M0, 0, and then I'm going to use the XE and minus YE coordinate, and then again the same, except this time it's going to be with plus. Okay, now here I can compute a base angle, and this one is going to be 360 over the number of slices. And here I can compute a current angle. So the current angle is going to be minus ns times the base angle. And here I'm going to have transform, and it's going to be rotate, and here I interpolate the current angle. And to see things better, I'm going to set a custom fill. This one is going to be an HSL value, and for the hue I'm going to use that current angle. I'm going to max out the saturation, and let's say the lightness is going to be something like 35, and now they should look different. Okay, good. Now the next thing that I want is to make those triangles pie slices. So for that I need to emulate the arcs with cubic curves. So I'm going to have a constant for the cubic curve. So this is going to be the factor to multiply and get the position in between the endpoint and the point where the tangents at the endpoints meet. So this is going to be my factor. And then I don't think I need anything else before computing the control points there. So I'm going to have C times XE plus 1 minus C times the coordinate of the point where the tangents meet is R over cosine of half the angle, and that's not going to work like that. And for the y, it's a lot simpler because the coordinate of the point where the tangents meet, the y coordinate is 0. So I'm not going to have that second thing there. So yeah. Okay, so these are the control points. And if I take this and put it here, and I'm going to okay, and this is going to be with minus, and I'm going to replace this here, C0. Now I should have the whole perfect rounded pi. Now, in order to round the first edge, the one that's aligned right now, and round it similarly, what I can do is rotate these control points around the center of mass of the triangle. So if you remember, these are the triangles. So I want to rotate the control points around the center of mass. Okay, the center of mass is at the circumradius 0. So the circumradius is the x-coordinate and 0 is the y-coordinate. So the circumradius is going to be 2/3 of the height, and the height is xe. So 2/3 times xe. And then, because the rotation doesn't happen around the 0, 0 point, it happens around the RC 0 point, I'm going to compute this difference that I'm going to be using, xc0 minus rc. And then in computing the first control point, so the one rotating this point, yc0 minus yc0, I'm going to have add again this rc that I'm subtracting here. And then I just have rotation, like I'd have rotation around the 0, 0. So dx times, okay, so first of all, I need a rotation angle. So I'm going to have a rotation angle, and this one is going to go anti-clockwise, so that's a minus. And it's going to be 2 pi over the number of edges of the triangle. So it's 2 pi over 3, because I have 3 edges in a triangle. And something else I need to compute here, because I don't want to keep computing it, is the cosine of this angle, of this rotation angle. And then I'm going to have the sine pretty much the same. And here I'm going to use the cosine. And then I'm going to have times the sine. Okay, and it's going to be pretty much the same for the y, except here I don't have any sort of offset. So I'm just going to have this cosine, and this is going to be sine. And the thing is, here I'm using the minus, so this is going to be minus there. Okay, and for the second control point, I'm going to have something similar, except this is going to be 1, 2, and I'm going to use this point with plus YCO, YC0, and this is going to be like that. So if I take this here, and again, I'm going to have something like this, get that out of there, and this one is going to be 1, 1, and then I'm going to have, okay, 1, 2. Okay, and now I have those nice rounded arcs there. Okay, that's good. Now the next thing that I want is compute the current state of the rounding, so where I am in between straight line and arc. So what I'm going to do is here I'm going to have the current values, and in between the initial state and the final state I'm going to have this k factor, and this goes from 0 initial state to 1 final state. So here I'm going to have xc0, the current one, which is going to be k times the control point, the endpoint, sorry. So because initially it's at the control point, so 1 minus k is going to be 1 initially if k is 0. Okay, and for the y it's going to be the same, except obviously it's going to be y here and y here as well. And I'm going to have similar things for the other two control points. Okay, so this is going to be 1, 1. 1, 2. Okay, so here it's going to go the other way, and the endpoint is 0, 0. So I'm not going to have that. I'm just going to have 1, 1. And here again, I'm going the other way. So here I'm going to have the control point, and here I'm going to have the endpoint. And since I'm going to have the one with minus, this one here, it's going to be minus there. So yeah, this should work. Now let's see. We replace with the current values. Okay. Now one more thing I want to compute here is the maximum distance it goes out. We're going to take it to be r, and we want to go from 0 to that maximum and then back again. So that's pretty much like 1 minus a cosine over 2. So that's going to be a 0.5 times, and the maximum, the amplitude, is going to be the radius. And then I'm going to have 1 minus cosine, and this cosine goes from 0 to 2 pi, so that's going to be k times 2 pi. And then I'm going to have something similar for the rotation angle. So I'm going to need to set a rotation angle in degrees here, and this one is going to be 360 over 3. Okay, I think that works. So this is going to be the angle, and this one doesn't go back, so it's just going to be 2 pi. And here I'm going to set on the same slice set attribute, transform, and I'm going to have translate, and here I'm going to interpolate that d 0, and then I'm going to have rotate, and by that angle a, and around the point at the center of mass, which is RC0. Okay, so this is messing the transforms that I've set here. So what I'm going to do is take that out of there. I'm going to have a group, and like this. Okay, now this works, and I'm going to move on to the animation. I'm going to set a total number of frames. Now I'm going to collapse this. I'm going to set a total number of frames, and let's say this is going to be something like 40. And here I'm going to have an animation function, which is going to take the current frame, 0 by default, and I'm going to make this self-invoking. Okay, and here, first of all, I'm going to compute the index of the slice I'm currently animating, and this one is going to be the current frame over the total number of frames. And I'm going to floor this, and after I've done this, I'm going to take modulo ns to get the frame I'm currently animating, and then I'm going to get where I am in the animation. So that's going to be f modulo nf over nf, and I just want half of that, 0.5. Okay, so what I'm going to do next is have set state, and here I'm also going to have k, and then I'm going to do the same for I minus 1. Actually, this is going to be plus ns modulo ns, so I don't go out of bounds, and it's going to be k plus 0.5, and then I'm going to have something like this, but only if k is 0. I'm going to have, for the one before the previous one, so here I'm going to have just 1. Okay, and then I'm going to have a request animation frame and bind this, and I need to increment the frame, the current frame. Okay, so yeah, this looks like it works, and I'm going to remove this fill from there. Okay, okay, that worked. Now something else I can do here is when I compute this stuff here, I'm just going to round it, because that's why I've been using such large numbers. Okay, and here as well, I'm going to have something like this. I'm going to round these values. And I'm going to round this translation value as well. And this thing here, it's not going to be rounded, but I'm going to do 2 fixed 2. And one more thing I'm missing here is a rotation on the SVG. So SVG style transform it's going to be rotate, and I need to interpolate the frame, the current frame, degrees. I think that may be too much. Yeah, it's too much. Something like this better. Okay, and one thing I don't like is that I have those thin lines in between the slices. So what I'm going to do is close this path. And here I'm going to have, oh come on, battery warning. Okay, path. I can finish this before it dies on me. And I'm going to have stroke, black, stroke width, 2 pixels. Actually, make it red for now to make it more obvious. And I'm going to have vector, non-scaling stroke. Okay, so yeah, this works, and I'm going to switch back to black, and I'm going to get rid of that scroll bar. So body, display, flex, and then I'm going to have height 100, SVG, flex 1, also here, no, not there, here, overflow, hidden. So that should do it. Okay, so yeah, this works. It works if I change the layout, as you can see, and it's responsive and everything else. So I hope you've enjoyed this video, and this is it for today.